Hi all, this is our practice problems 22 from section 5.8 on antiderivatives. So remember the big thing that you're doing here is you have your reversal of the special derivatives. And then you also have the reverse of the power rule. So we're adding 1 to exponents and dividing by the new exponent. So here we go for number 1. In order to find our capital F of x, that 3, we're just going to put an x with it. And then we're going to take negative 2. We're going to add 1 to our exponent to make it a 2 and divide by that 2. And we're also going to add on a plus c. If we simplify that, that becomes 3x minus x squared plus a constant. And that's my answer. For number 2, for our capital function f of u, we're going to add a u to that 1 to make it u, plus 1/2 u squared, plus raise it to cubed and multiply by 1/3, or divide by 3, your choice. And then we're adding on c to the end. Number 3, before we can take the antiderivative, we need to rewrite this. This is 3 times t to the negative 1/2 power. So now when we go to find our capital F of t, we're going to leave the 3. We're going to increase our exponent by 1 from negative 1/2 to positive 1/2, and then multiply by its reciprocal, which is 2 over 1. Don't forget to add your plus c. That's going to give us, not plus, but equals 6t to the 1/2 plus a constant. Okay. Same thing with number 4. Before I jump in and take the antiderivative, let's rewrite that. That's 6x cubed plus 3x to the negative 2 minus x. So now when I find my antiderivative, capital F of x, that's going to be keep the 6, raise the exponent to 4, divide by 4, plus leave the 3, add 1 to the exponent, so x to the negative 1, and divide by that new exponent of negative 1. For the x, we do minus, add 1 to the exponent, so that's 2 over 2, and plus c. To make it pretty, we just reduce by 2, so that's 3/2 x to the 4th. Let's see, that's going to be negative 3, and then my x to the negative 1 means an x on the bottom, only underneath the 3, minus 1/2 x squared plus a constant. On to the second page. Okay, we've got this one. It's already written as our exponent, so we can jump in with our antiderivative here. So capital F of t, raise the exponent by 1 to 5/2, multiply by its reciprocal, which is 2/5, plus leave the 2. My t, the exponent, new exponent, is going to be 3/2, and multiply by its reciprocal, 2/3. Minus, leave the 4. The t will become, add 1 to negative 1/2 to get positive 1/2. Multiply by its reciprocal, which is 2 over 1. And add your plus c. So it's going to give me 2/5 t to the 5/2, plus 4/3 t to the 3/2, minus 8 t to the 1/2 plus a constant. Number 6, remember that just like in section 4.2 when we were learning derivative rules, I don't have any rules for division or multiplication when it comes to antiderivatives. So in order to do this one, I'm going to have to divide through by the x squared first. So we're going to take the x4 over the x squared minus the 1 over x squared. And that's going to reduce to x squared minus x to the negative 2. Okay. And now I can go ahead and take my antiderivative. Capital F of x is equal to, raise my 2 to a 3 and multiply by 1/3. Minus, make my new exponent negative 1 and divide by that negative 1. And add your plus c. So this is 1/3 x cubed plus 1 over x plus a constant. Number 7, again, I don't have rules for multiplication. So before I get going, we're going to go ahead and multiply this out. This is 2y squared plus y minus 4y minus 2. So that's 2y squared minus 5y minus 2. When I go to find the antiderivative here, capital F of y, leave the 2, increase the exponent to 3, divide by that 3. Leave the 5, increase the exponent to 2, divide by the 2. And for the minus 2, we're just going to tack on the y and add a plus c. And I don't have to simplify anything there, so I'm going to leave it as is. And I think this is the last one. Yep, last one. So before I get started here, I'm going to go ahead and two things. I'm going to rewrite these as sines and cosines, and then I'm going to multiply through and then see what happens. So if this is sine x, cosine x, cosecant x is 1 over sine, and secant x is 1 over cosine. And that way, when I distribute this, one of each term is going to cancel. So when you distribute to the first term, the sines cancel, and I just get cosine of x. When you distribute to the second term, the cosines will cancel, and you're left with just a sine x. So now I can go ahead and jump in and find my antiderivatives. So what function has as its derivative cosine x? That would be sine x. Plus, what function has as its derivative sine x? Well, the derivative of cosine is negative sine x, so I need a negative sign, and I can use cosine x. And don't forget your plus c.